We are going. Getting things cleaned up here, and we can get started. Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night. Today we're going to keep working on weapon functions. We have 29 weapon functions remaining. It's going really quick. Weapon 0 should be done hopefully in a few weeks. There's a few that I was looking at yesterday after the stream that are tougher than I was expecting them to be. But with time, everything can get done. So let me tell you a little bit about the Castlevania Symphony of the Night decompilation project, and then we can get into some more decompiling. So the Castlevania Symphony of the Night decompilation project started by looking at the PlayStation version of the game and how to decompile it through research there, as well as looking at other versions of the game like the PSP version. We found that most, if not all of the versions are mostly about 99% of the same code base. There's differences obviously between some of the games, some of the interfacing between the systems, and also some of the additional characters and other things that were added, fixes that were done along the way. But what we'd like to do is go from the files that were on the original game disks, be able to decompile the code in those files, and compile them back to the original objects as they were in the original game. And then that allows modders and other people who are researching the game, speedrunning the game, randomizing the game, allows them additional resources for doing that thing, and people who just want to learn about how games are made in the various eras, PlayStation, PSP, even up to Xbox 360, how those games were made. If you want to know more about the project, SOTN.z.dev is where progress for the project can be monitored. There's still one function left in the main Dracula binary. I looked at that a little bit this weekend as well. There's some complexity there that makes it harder to decompile than some of the other functions that I've looked at. I'll probably come back to that every once in a while and poke at it and see if I can find what's missing there. The Richter program is completely done. We're working on weapons. There are 29 functions left in weapons to be decompiled. And then we have several stages that have been completely decompiled or are most of the way decompiled. NO3 is the stage that we're currently working on that probably has the most work remaining. If you want to know more about the source code, you can go to the GitHub repo, which is linked from SOTN.z.dev, and see what is going on. Currently outstanding are... so we worked on the Weapon 48 function, which was Icebrand. No, not Icebrand. Thunderbrand. And then after the stream, I went through and worked on Firebrand, which is effectively the same, slight differences, but relatively minor. Code-wise, those functions were nearly identical. And so those are in PR now being reviewed. One other weapon is in the progress of being reviewed. So in the repo now, there's 32 weapon functions that haven't been compiled, but with these 3 that are out for PR, there is 29 remaining. So yesterday we went to the duplicates list. So this is a list of functions that have been duplicated across several different modules. And I looked there to see which functions within weapons we can look at. And just chose these 2 at random. We can look at 53 and 56, the function pointers there, or 54 and 56. The function pointers there as well. I do think I looked at these yesterday. But we'll take a look at those again and see if there's a reason we shouldn't look at these. I'd like to fix this report so it doesn't put the relative path in. This is on the longer side, but not overly long. So the way that I find the next function I want to decompile is look at the functions that have not yet been compiled, and I have been sorting them by size and just going smallest to largest to make things easy. I'm going to look at these remaining duplicates and see if there's any that are particularly large or small. I always say that large doesn't mean hard and small doesn't mean easy. But sometimes the larger functions are harder to get through in an hour-and-a-half stream. So entity weapon attack for 54 and 56 are on the larger side. They're about twice as big as the smaller functions that are remaining. And 08 for 49 and 48 are kind of right in the middle. Let's take one of those, and we'll see if we can... actually, 48. I'm not going to take 48 and 49. I was looking at 48 yesterday and ran into some issues there. Oh, no, 48 and 49 is what we did yesterday. 53 and 56, let's look at those, sorry. 04 for 53 and 56. And those are among the bigger ones as well. So we can try entity weapon attack for 54. Or we could go, let's do entity weapon attack for 15. Because it's on the smaller side and we could get through that. I'm changing my mind again. We'll go for the bigger ones. Okay, so first we want to see if there's a jump table in the function. The jump table will just tell us that we need to get data that's defined outside of this file, and it doesn't look like there is. Let's open weapon 54 and see which weapon we're looking at. Oh, thanks. So Biz Murphy has been keeping a spreadsheet of the remaining weapons that need to be decompiled. And that's classified. There's, he probably knows offhand, but 8 or 10 functions that are the interface to how the game engine communicates with each weapon that's allocated. So for each of those functions, those 8 or 10 need to be implemented. Sometimes those functions are just empty functions that do nothing. The ones that are remaining are obviously functions that do something. So I'm going to open my... terminal is going slow. So we're going to look at 54. I believe that's the one I said. Girthing. Too many things open. Let's see if the wiki can tell us what girthing is. A bloodthirsty sword of finality. These are my favorite weapons in RPGs. Anything that I can gain health back while doing damage, to me, is an enjoyable weapon to use. And equipment, I love vampiric equipment. So this will be interesting to see what's in here. And so here's our Alucard wielding Girthang. So this, looking at this weapon, looking at the Girthang implementation, it only implements this entity weapon attack function. Everything else, except for get weapon ID, is unused. Or I should say, the empty implementation. Nothing happens when those functions are called. Symphony of the Night is interesting, in my opinion, because it's implemented as if it's implemented in an object-oriented programming language. There are entities, and those entities have methods that are seemingly overridden. There's no inheritance, really, but the general concept is the same. You have some opaque pointer to an entity. You call methods that are stored in fields, or you call functions that are pointed to by fields, and those act as methods on that object. So I'm going to copy this function into decomp.me. And we'll get started. So decomp.me is an online editor for decompiling programs. It hosts a bunch of decompilers and compilers and tools for diffing generated assembly versus extracted assembly. Off screen, I'm getting the assembly from this function. Oops. Sorry, my terminal is not scrolling. Alright, so I'm going to go to decomp.me and start decompiling. So there's tools specifically for the PlayStation for different versions of the PlayStation SDK and the compilers that were associated with those. We have a preset for Castlevania Symphony of the Night. I paste in my assembly. This is the target assembly that's been extracted from the weapons file on the disk. And then a context is function signatures, structures, and other things like that that acts as a header file for the decompiler. And the decompiler is going to go through now and do its best effort to get a function that should compile back to the original assembly. But a lot of times this happens where we get a function that does not decompile fully, and we have to go through and give some hints as to what different structures and pointers are so that I can do that decompilation. So I'm going to go through and clean this up so that we can get to a compiling state, and then we'll go through and try to match everything that's remaining. The sprite parts, I know offhand that this is going to be an array, and it looks like some of these others are going to be as well. Let's see if we can tell what the types of each of these things are. So some of these types you can infer from the context where they're being used. So this temp s3, make sure that I have this up. This temp s3 is a pointer to some offset into this array. One of the hints about what this array might be is we're multiplying what's going to be the index by 16, which suggests to me that this is an array of structures of size 16. And we can find that in the extracted data and see if we can get a better idea of what type of data is there. So it looks like we have 2 pointers, and then the Splat64, which extracted this, decided that the next 2 values were also 32-bit values. I'm guessing they're not actually 32-bit values, but they're extracted that way because Splat64 wanted to keep everything uniform. We can see if this has been used elsewhere. It has not. And we can also see where this reference is being used. If it's a argument to a function, and some of it is. So this update unarmed animation is using fields. So it's using the pointer at offset 4, which is that second pointer. Sorry, let me go back here. So this is the second pointer. So we know that there's 2 pointers at the beginning, and those are being used as arguments to this update unarmed animation. Also, at offset A, this value is being used to get the ID for the sound effects. And offset A is probably going to be 16 bits. So let's go through and look at some of the structures that are of size 16 or hex 10, and see if we can find anything that looks similar. So I'm going to go through, look at game first. So a comment about going through and doing Unix commands. I've been using Unix over 20 years. I gave a talk once about Unix as an IDE, and that's kind of how I treat it. I don't use Eclipse or Visual Studio Code or any of these other things. The tools, like people get good at any particular IDE, you can do the same with any Unix-like operating system. And then you can be like the kid in Jurassic Park. And when you come to a Unix system, you say, it's Unix, I know this. And usually it's pretty similar, regardless of whether it's Linux or a proper Unix. All right, so we're looking for things of size x10. It's not an S vector or a tile definition. So we're going to find something that, and it's possible that it's none of these things. We could look at entity, but I don't think it's going to be in there either. Thank you. we should look at other callers of update animation. And then we might be able to get that that type. Okay, so we have an animation. So we're passing frame props and frames. So let's look for the animation. I don't know why that one didn't come up. Yes. Oh, because we don't have a size associated with it. That would help me in the future. All right, so our first unknown is going to be a weapon animation array. Oops. And this is going to be a pointer to a weapon animation. And for fun, we'll call that one. I won't rename it yet. No, I will. We'll call it anim. Thank you, Biss. All right. Now we have this next, and these might all be similar. So this is the same idea. So this is likely going to be a 32, or sorry, 8-bit array, because we're not multiplying the offset index by anything. So I'm going to take the guess and say that I'm going to say it's an unsigned 8. We'll figure that out when we get further in. And the same thing here. All right, so I'm going to disable built-ins to get rid of these warnings about the libc functions. So we have on line 40, there's a global that I don't have a declaration for. I'm going to, off screen, I'm going to go find that declaration. Saved reg S4. That looks like something that maybe M2C created, saying that this function is reusing register 4 even though it's not been set. That'll be interesting to get to. We'll get to that though once we've got something compiling. Meanwhile, I'll put a declaration outside the function. And we'll say it's assigned 32, which is the register size. Okay, and then so 47. So it doesn't know what unknown 31 is. I ran into this problem the other day as well. So we haven't... So this is params, but it's the top byte of params. So for now, we'll put that in as a shift. And see how that works out. 51. So this is where we have array access. 52. We have access to weapon animation. And unknown C is frame start. I'm converting the field names to offsets based on structures that are already included in the repo. So we know what these structures are, we know what their shape is, we know what the offsets for each of the fields are. At this point, the decompiler didn't know, and I could have actually gone through and declared these correctly and then had the decompiler go back and fix them. I'm a little far in now to do that. Should we do it? Yeah, there's nothing that can't be reproduced. So once we know what the types are for different fields, we can paste them into the context and then decompile again. And then the decompiler will know what some of these things are and hopefully have a better idea of what those fields are. And it got through most of the things that I would have had to do manually, so that was a smart move. I still have to deal with this register, which I'm interested to see how that works out, and then the flags, or the params that are offset. I don't know if this is going to be how they're accessed or not. We'll see. So we're at 70%. We have to go through and fix all these access to player fields. These are fields that are mapped symbols so that we can find them easily, but are actually accessed through their struct fields or through arrays in that case. And we just have to go through and update those to be what we expect. And as we do that, the assembly that we're generating from this code will get closer and closer to the target assembly. Let's see, line 3. Oh, I screwed up the G player. That's okay. We'll go back and get those. 35. Is that it? Okay, so same thing with the G player. These are array access. And then this last one here. All right, so we're a little closer. I want to see what var_s4, how that ends up being used. And why the decompiler thought that we're reusing that register. I don't see anything in the generated assembly yet that would suggest that we need to use that, but maybe something will come up. This gEntities pointer also needs to be replaced with player. The decompiler knows that it was accessing the first element of gEntities, which is the player entity, but it doesn't know that we like to use this macro to access it instead. All right, so the next ones are the G APIs. Those are also accessed through structs. And that gets us a little closer as well. We have some interesting logic that it looks like is probably less complicated than what was generated by the decompiler. It looks like the decompiler thought we should and in this part of the way through this backside of this condition. But in each of these cases, we're going to fall out of these blocks and then end up doing this assignment. Usually when I see these go-tos, I will, if it's a single line like this, I'll paste that in where the go-tos are. And we should get the same or similar code compiling. There's this case here where if we hit this case, we're not going to do this multiplication, as well as this case here, we're not doing the multiplication. So unfortunately, it's not as simple as just moving this outside of the conditional. But I will move these up and see if this can be refactored later. And so we're at 79.8, and we do that. It drops us down. I'll keep these here to get rid of the go-to, and then as some of the logic shakes out, refactor as possible. Especially once we know what these. So in this case, this it was going to that line, but ultimately it was setting var a2 to 0. Yeah, yeah, and it's kind of sometimes it's nerve-wracking. Like, oh man, this. So Biz Murphy commented that it's weird looking. Yeah, sometimes they are, and you get that like endorphin panic rush, like, oh, am I going to be able to do this one? I usually they work out, and they're simpler than expected. When there is a huge condition and then there's a destroy entity right at the end, I like to flip that around. And this logic isn't going to be that bad, but effectively we need to reverse all of these conditions and change the ands to ors. If you remember any predicate logic from school, this is it. So if this is less than, and this is greater or equal to, and then these are going to become ors. And this is going to equal 0. And then we get rid of this down here. And that got us a little closer. And gets rid of a level of indentation, which hopefully makes it easier to follow and read. There was a discussion in the Discord about how close, we don't know the variable names for any of these functions, but how close is the code that we're regenerating to what was actually part of the game. And there's dozens of different ways that any of this code can be written. It will compile to exactly the same binary, which is a pretty neat idea. But we all get to impart our own kind of flavor into this, and we don't necessarily know. We know some of the idioms, I think, that were used throughout the game because they seem to reappear over and over, and you have to get them to all compile in their different forms and different functions. And then again, for like the PSP version versus the PlayStation version. But ultimately, we're kind of interpreting how these things were written originally, and it's kind of fun to see everybody's flavor and character as that happens. All right, so I'm going to go through and start figuring out what some of these variables are, if we can name them or get rid of them. And starting up here, I mentioned this at the beginning, this temp_s3 is an animation, and it's the only animation we have, so I'm going to replace that with anim. And then this frame start, I'm going to get rid of that temporary variable and use it directly. At this point, I'm not worried too much about the flow of logic. I'm not even worried too much about the assembly, which is coming together. I just want to be able to understand what's happening, and for me, understanding is simplifying and naming things primarily. This var_s7, this is going to be the animation index. And by reusing a lot of the names and variables that we've already come up with, you start to see patterns that are familiar. This primitive var_s0 and var_0_2, those are going to be offsets, or those are going to be pointers into the primitives table. And it's unlikely that they are going to be used at the same time. So all the var_s0s, s0_2s can be var_s0s, and all the var_s0s can be prim. And we can get rid of one of those. It's amazing too, I think, going through the decompile. The decompiler will produce dozens of temporary variables. And when you get towards the end and you almost have your fully decompiled function, the actual number of variables that are used in these functions is extremely minimal. I did run in, the ones I was doing yesterday had quite a few, but I don't think that this one will end up having very many. All right, so temp v0. This is our primitive index. Along the way, cleaning all these up, I'm not expecting that our that the target and current are going to get any closer. Sometimes they do by reusing variables places. It understands that the compiler understands that it can reuse registers in different ways, and so those will fall into place as well. One thing that's odd and that I haven't seen, or usually see, I should say, when an entity is allocating a primitive, if this allocation fails, the index will be -1. And often when that happens, the entity will destroy itself. In this case, it doesn't. It just doesn't set up the drawing context. I'm not familiar enough with the drawing code to know that whether or not the drawing code will also realize that there's no index to draw and do the right thing. But the error handling here seems a little different from elsewhere. This index, we actually don't need a separate variable. We can just assign directly to the field. And by renaming that other one, I misnamed these. So this is going to be a random color, and it's when it's assigned to all of the color fields, usually that means it is a brightness. In this case, it's just the green and the blue, because red is, back in the animation, it's a red weapon. So the green and the blue influence the brightness, not they're not there for shading in one range of green or blue or the other. So we'll just call this brightness. Yeah, that makes a lot of sense. Yeah, in the other cases, the comment was they want the attack and everything to succeed regardless of whether the animation succeeds. And for a primary animation, that makes a lot of sense. In other cases, it's particle effects and things that don't, are just visuals. They don't affect anything that's happening to other entities in the game. So V0, I've noticed that well, I was going to say that it's used frequently for indexing during a for loop, what we usually use an I variable for. In this case, it is just a condition. It's not anything else. No, it is, yes, so it is a for loop. So varus1 is being used for the I, so we can change this to a for loop. And clean everything up accordingly. And it's going to be similar down here as well. Some of these will have to be worked out. A lot of times the temporary variables here are not needed as well. In this case, it's doing some addition based on a condition, and most of that can probably happen inline. I'm going to clean up this loop down here as well. And so now everywhere var_s1 underscore 2 was needs to be an I. Okay, so I'm going to go through these and try to get rid of as many more as I can before going on, or rename them. Oh, I missed one. Be nice if the decompiler was mixed somewhat with the permuter and would do some of these permutations by itself, because a lot of times these additional variables in other fields aren't necessary. So here we have a case where we're setting a variable to -1 unless we're facing left, and then we're swapping it. So what is the offset from the player effectively? Are we going left or right? And unless we have another, we do have another x. So this one's only being used for x2. So I'm going to name that one x2. And it's possible that it falls out later. It doesn't need to be used. And this is an interesting construct, and I've seen this too in different weapon animations and other animations. Based on the height or the Y value, that also affects the shade of red that's being used, or the red intensity. There's a lot of graphics tricks. I studied computer graphics a long time ago, and it's interesting to see, never in a game implementation perspective before, but it's interesting to see the tricks that they use for motion and color to get different effects on the screen, and neat to see the art mixed in with how it's programmed. All right, let's see which other ones we still have going. It's also interesting to see how much is not necessarily sprites, but programmatically created graphics as well. This var a1 can also be x. We can reuse that. So this is an index into an offset that's being used for both x and y. These arrays are offset from each other by eight bytes. I want to look at that. There's only eight bytes in these, but we're got it. This is what clamps our index here. Okay. The logic above is what clamps the index into those arrays. So we only have 8 values to choose from, but we're iterating 12 times. So we'll have to get through that shortly. So this is basically an index into one of these offset arrays. And so here's a case where the decompiler thought that we'd use this var s4 variable, but up until this point, the decompiler didn't see that it had been set. Yes, that's very... So it is possible that this is... and likely that this is not a byte array, but a 16. That's a good call out. So Biz Murphy was saying that when indexes are multiplied by 2, we're probably looking at a 16-bit value instead of a 8-bit value, and I agree. In all cases, now that I'm looking at it, we end up with this offset. Or this multiply by 2. And so we're able to get rid of this and just set our index to these values, and then we'll change the type, and we should get the same thing. What I don't know, however, is... So this is relying on something else to have previously set this index. and reusing that index. Let's get rid of these multiplications first. It may be so sometimes, yeah, the decompiler can be a little dumb about how this branching worked. This branch, the duplication was from when I replaced the gotos. So this was all jumping basically to the same spot at the end and doing this effectively offset equals var_s4. And so we can pull that out again to the end, and in all cases that probably works. There are situations like this, however, where var_s4 was never set and it's relying on the previous value. And so in this case, that's getting us further away. We could look at the assembly there and see what's going on. We know it's definitely not this multiple of 2 that's happening. There is a 0 assignment that is missing. Or no, I'm sorry, there's a 0 assignment that we have that was missing from the original. I've seen this a couple places too, where I is set at an odd place. And up here we're getting we're loading the offset of S2. We have a register issue. So that's 124. So this primitive index is being reloaded, and we'll have to figure out why that is as well. The logic in this isn't too terrible, but there are definitely some odd things. Getting this the same, this variable is unnecessary. The decompiler will do this. So this is the second instance where it's done this as well. It pulls these conditions out into separate statements that are unnecessary. Of course, I screwed this up. 87, so it does not equal 0. So we just want a condition. So because I had that originally as a these actually, I wonder if they're fixed. So it looks like this temp 1v4 can go away as well. Okay, almost done. Getting rid of these unknown variables. I'm going to try to get rid of this. And so I would imagine that, so offset index currently isn't being set. There may be a missing statement to set that. There's going to be some out of order statements up here as well. So looking around line 51. Oh, I missed this. Let's look at the decompile again. Oh no, it's an or equals. I was reading that as a not equals. Yeah, so the comment is within this loop down here, and we'll go down to those lines on the right here. Is offset index set? And if it's not, is it going to be? I actually don't think it was set. And the decompiler saw that, and the decompiler said, this is being used as the index to that array, but in some cases it's not set, so it's going to be set to whatever was currently in the register. And at this stage in C compilers, if you didn't initialize a stack variable, you would just use whatever garbage was on the stack. And by default, wouldn't warn you either. We get warnings actually now in the project when we're compiling and don't set variables, but I don't think... I've seen other cases like this where a variable has code paths that where it doesn't necessarily get set. What is odd, however, is that this is being set, or this is being loaded almost as if a reference is being taken to this outside, and we can try that. You might be right. I might be misinterpreting. So let's grab a reference to this array. It could be that this X is being set at each of these locations. Let's look at the decompile again. And then the compiler knows that it can pull out access to this global and store that in a temporary variable. I'm going to try to do it manually first, and then if that works out, I may try to rewrite that as well. No, I won't. What did I call this? Yeah, so this gets but puts in the wrong register. Looks like that primitive index might be so on that hunch, I'm going to rewrite this. That's right. Some of these are a pain to refactor when you're not sure if this is how it's going to go. And this is one of those. It's one of those times where I'm not sure. It's a hunch, and we'll see how it works out. Oh, interesting. Yeah, that is a good point. So this could be a switch on animation current frame. Do you know of any other functions that switch on that? No, it didn't like that at all. We'll back that out. Let's go and look for that. So what would a switch look like? So if it's 22, we're going to do offset 1. Let's write the switch. So this is every case. So this is our default case, except for thank you. I don't have enough screen real estate to have all these things open and see OBS at the same time, so sometimes I forget to switch back. All right, so I'm writing this switch. So we have an explicit case for 22, which is to set offset index 1. Then if we're less than 23, which is a whole bunch of numbers, we're going to do offset 0 unless we're D, which then we'll do nothing. So I'm assuming that the less than 23 is the default case. But we will see. It may not be. The range here is so high that I'm not sure yet that that's going to be the case. So then we have a, for 2C, if we're not 2C, the offset index is going to be 3. I'm going to rewrite this. Just as the condition. So if we're at frame 22, so this is if we are 2C. Otherwise, if we are 3, so maybe it is a switch, an odd switch. It seems like these are the only cases where something gets set. We can go back through the assembly as well and look at that, but we can switch that to a switch. Are you kidding? This makes a lot more sense. I don't think we're going to get through this one completely today, and that's okay. I have a hard stop in about 15 minutes. Oh, Biz Murphy, you're a genius. Look at that. Everything fell into place. So we're missing a move, and we can try... that's actually our move here. I saw this yesterday as well. Originally, this may have been a while loop. It seems to fit the structure of a for loop otherwise. So I'm going back up and seeing if there's anything obvious for control flow that might be screwing up registers or anything else down here. There is still an issue of these offsets being out of order. I'm going to try to redo that now. I'll pull this up. No, it didn't. I was hoping that the compiler would see that regardless of which branch it took on the case, it was going to be accessing this array. And because it's accessing that array regardless, it can pull that up into a variable. So I wouldn't have to do so manually. It doesn't seem like it's going to be that smart, however. So somewhere before the array, we're pulling this in and then using it down here. Unfortunately, I think that's correct. I don't really care for that. It looks like this may be happening above. That's pretty common. Often X's and Y's are set relatively close to one another. And they're usually in order as well. Not always. The second offset of S2 is, so that's this access. Is happening out of order. Okay, that ordering is correct. For this array, it is actually accessing it as an unsigned byte, even though the data looks like a... Oh no, that's my fault. I didn't change that one. That should fix those. Okay, now we're rolling. We're getting close. So we have some register differences, and the register differences may be due to ordering, and they may be due to something else unrelated. So I'm going to go back up to the top where there is some other mismatch and see if there's anything obvious up here. So around line 79, there's going to be some ordering issues up here. We can clean those up. And those go into place. We have the condition of this loop, that was also 12. There's a shift by 4 that's not happening. So this is trying to see if I is being used as an index, or why there would otherwise be a shift by 4. I don't see that obviously at the moment. These are out of order. Those fall into place. And then there's going to be a move. So there's still a little bit more cleanup. We're at 96%. That's pretty close. That's going to be as far as I'm going to be able to get to on this stream. But I'll come back through this later this afternoon and get this one submitted as well, along with its match. So if you weren't here at the start of the screen, thank you. I get some of the mnemonics incorrect. I'm semi-dyslexic, and so seeing a bunch of random letters together, and that's one of the reasons I go through actually and fix the variables as well, because having a bunch of things all named the same with one numeric difference just does not work with my head. So yeah, I was saying a shift, it's a sign less than immediate. We can go back and look at that one again. Let's see. Somewhere around line 84. Now it looks like these are out of order 54. This is Simon again. Oh, you're welcome. I hope people find this somewhat enjoyable, somewhat educational. I will never admit to being the best decompiler. I will try to do my best, and I'm getting stuff submitted, which makes me happy. I'm getting hopefully moving the project in the right direction, and I want to encourage other people to do the same. If you're interested in decompilation or Castlevania Symphony of the Night and how it works, go to SOTN.z.dev. There you can get a link to the GitHub page, which has all of the work that many great contributors have done to get this project to where it is. You can join the Discord, and there's a lot of discussion there about how different aspects of Symphony of the Night work, what are possible ways that we can mod and change and expand Symphony of the Night going forward, how it can be made portable, a lot of work looking at the different versions, and just interest in the game in general. I think it's really neat how kind of the interest and passion for the game is going along with finding out how that game works and getting into the details down to how the code may or may not have been written. So I want to thank everybody. I have to go take my car in, get some recall work done, and I'll be back tomorrow, and hopefully I'll say I submitted this for PR and you guys got to watch most of it, and I can cover the details of what was causing challenges. And this probably would have been a good time, just for the stream's sake, to throw this in the permuter and see what the permuter would have come up with. But if I don't make any progress, we can do that tomorrow as well. And we can look at the remaining functions. So if I do get this finished today, we're at 29 weapon functions that haven't been decompiled yet. This matches another one that'll bring it down to 27. There's another pair that can be decompiled that I'll probably look at as well, bringing things down to 25. There are a few functions that I have looked at that at first crack were not going the way that I wanted them to, so there's some hard work still to be done within the weapon object, but it'll get done. So thank you all for watching. Follow, comment, like, subscribe, give me suggestions. I'm happy to do things. People suggested speedrunning last week. Nobody was on the stream when I did a speedrun. So I don't know if there's actually interest there or people were just trolling, but it was fun to do. This would have been a terrible speedrun because we're at an hour and a half and nothing was done. But that's it. See you all tomorrow.